matrix E, so that when E is multiplied on the left by a 5 by n matrix A, the resulting matrix is the same as if we had taken that matrix A and swapped row 1 and row 3, and also replaced row 5 by row 5 minus 3 times row 2. Now, if you can't come up with such a matrix off the top of your head, we can break this up into a couple different parts. Because we know that swapping row 1 and row 3 is the same as multiplying on the left by an elementary matrix. And replacing row 5 by row 5 minus 3 times row 2 is also an elementary matrix. And if we put these two matrices together, we can get the matrix E that does both of those things. So let's go ahead and do that first step where we create a matrix. And I'm going to call this matrix E1, so that E1 is the same as swapping row 1 and row 3. Now, in order to get that matrix, all we have to do is take the identity matrix, the 5 by 5 matrix, because of this 5 right here, and swap row 1 and row 3. And this will give us the elementary matrix, so that if we multiply on the left by E1, then that corresponds to swapping row 1 and row 3 on any 5 by n matrix A. Now let's go ahead and get our second elementary row operation here. This guy corresponds to replacing row 5 by row 5 minus 3 times row 2. And to get it, we just have to do that row operation to the 5 by 5 identity matrix. Now, to put these two guys together, what we have to realize is that what we want to do is take our matrix A, and we want to both swap row 1 and row 3 and replace row 5 by row 5 minus 3 times row 2. So if I do this, if I multiply on the left by E2, this is going to be take A and replace row 5 by row 5 minus 3 times row 2. If I then take E1 and multiply the result of this first multiplication here by E1, that takes the resulting matrix and swaps row 1 and row 3. So if we let this guy equal B, okay, then B is the same as taking A and doing both of these elementary row operations. So if we associate, just rewrite those parentheses in a convenient little way, and we define E to equal E1 times E2, then what we get is multiplication on the left by E by any 5 by n matrix A is the same as doing both of these elementary row operations. So all we have to do now is write out the multiplication for E, and here it is. Now, one question you might want to ask yourself is, did it matter what order I did these two operations in? Why did I do E2, E1 instead of E1, E2, the other way around? Well, the thing is that doing these two operations, they commute. And the reason they commute is you can go back to and think about these operations here, swapping row 1 and row 3, and replacing row 5 by row 5 minus 3 times row 2. If I did this operation first, and then I did this second operation, it's the same as doing this second operation and then this first operation. The reason is because what I do to row 1 and row 3 has nothing to do with what I do with row 5 and row 2. They're disjoint rows, so the operations are going to commute, and it didn't matter what order I wrote these two in, it's going to give me the same matrix here. So if you have any questions about this particular question, then go ahead and either ask me in class or ask them in the comments below. Thank you very much.